think for a second about how much of your daily digital life happens kind of invisibly. Email, social media, ordering food late at night. It all relies on this hidden network, right? Software talking to software.
Yeah, and that's the world of APIs, application programming interfaces. They're basically the silent workhorses powering so much of our tech.
And, while APIs might sound really technical, the truth is that well-designed ones are, well, fundamental to things we all care about. Smooth, reliable technology that can adapt and grow.
Definitely. A clunky API. That just means headaches for the people building stuff and probably a frustrating experience for you down the line.
Okay, so how do you actually build these invisible engines well? Turns out, just like in architecture or even coding itself, there are these recurring solutions to common problems.
API design patterns. That's what we call them.
Right, design patterns. Think of them as like tried and true blueprints for creating APIs that are predictable, easier to use, and ultimately, as our sources say, just plain better.
Exactly. And for this deep dive, we've got two really excellent guides. First, there's API design patterns by J.J. Giewaks. Gives a broad look at the general principles and these recurring challenges.
Okay.
Then we're also digging into designing APIs with Swagger and OpenAPI by Joshua S. Ponelet and Lucas L. Rosenstock. This one's a bit more focused, showing how a specific tool, OpenAPI, helps describe and refine API designs.
Got it. So, two complementary views. Our mission today is pretty straightforward. Pull out the key insights from both sources to help you understand the ins and outs of crafting effective APIs.
Yeah, we want to explore the complexities, the best practices, but without getting totally lost in technical jargon.
Exactly. The goal, as always, is to give you a solid grasp of the important stuff quickly, hopefully spark a few of those aha moments along the way.
Sounds good. So let's lay some groundwork. What is an API, really? Giewaks offers a clear definition. He calls it a specialized interface, mainly for computer systems to interact.
Right, not like the graphical interfaces, the GIs that people use.
Precisely. And he points out a critical difference right away. APIs are actually way more fragile when it comes to changes.
Fragile? How so?
Well, think about renaming a field in an API. Just one field name change. Any software expecting that old name, it's likely going to break completely.
Ah, I see. Whereas moving a button on a website.
Yeah, it might be annoying, maybe confusing for a bit, but you can probably still figure it out. The site doesn't just crash.
So that inherent fragility makes the design part absolutely critical.
Totally. Which leads to what makes an API good. Giewaks really emphasizes predictability and ease of learning.
Predictable and easy to learn.
Yeah. He argues you achieve this mostly by using simple, well-established design patterns consistently. If developers can guess how something works because they've seen the pattern before, they can learn it fast.
Okay, that makes sense. Now, bringing in Ponelet and Rosenstock, where does OpenAPI fit?
They see OpenAPI as this way to formally describe HTTP-based APIs. And that description allows tools to automatically generate code that can talk to the API.
So it's like a shared language, not just for people, but for machines too.
Exactly. Now, they're realistic. OpenAPI isn't magic. It can't describe every single nuance.
Right.
But its real power is in helping design discussions, making APIs easier to manage, and crucially, easier for other developers to actually use. It's that clear, unambiguous agreement.
Okay, so we've got the what and the why of good API design. Let's dive into some specifics. And where better to start than naming? Seems basic, but Giewaks really hammers this home.
Oh, yeah. He says the names you choose often outlive whatever your original intention was. They become fundamental.
And finding that sweet spot, right, between being super descriptive and keeping it concise.
Totally. His example is great. User-specified preferences tells you exactly what it is, sure, but it's kind of a mouthful.
Yeah.
User preferences probably better, but just preferences might
Yeah.
be too vague. Preferences for what? Context matters.
And consistency is huge. You can't call the same concept topic here and messaging topic over there without a good reason. It just causes confusion.
Drives developers nuts, yeah. Then there's pluralization. Simple, right? Book to books.
Usually. But then you hit foot.
Feet. Or person.
Yeah.
People. The guideline seems to be just follow standard American English rules. Keep it simple.
Another practical tip, include units in names if it helps clarity, like size bytes instead of just size.
Or dimensions pixels. Though Giewaks also mentioned you could use a single string for dimensions, like 10 Twitter by 768 if you have a well-known format. Trade-offs.
And context influences everything. You have to be aware of where a name is being used.
Right. And don't rely only on names. Use richer data types, too. They convey meaning beyond just the label.
Okay, good points on naming. Let's shift focus now to how you actually structure the pieces of your API, the resources.
Yeah, UX stresses a key shift here. Think about the things, the resources, not just the actions. So instead of send message, focus on the message resource within, say, a chat room resource.
Ah, okay. That lines up nicely with REST principles using those standard verbs. Create, get, list, delete, update. You apply those actions to the resources.
Exactly. And these resources can have hierarchies, like your chat room contains message resources. That parent-child thing has implications,
Implications
like access control. If you can access the chat room, maybe you automatically get access to the messages inside. And actions can cascade.
Right.
Deleting the chat room might automatically delete all its messages.
Right, which UX points out can be good and bad. Convenient, like deleting a folder deletes the file.
But also risky. You could delete more than you intended or grant access you didn't mean to.
And he also mentions singleton sub-resources.
Yeah, like a driver and their driver location.
Yeah.
The location's ID depends entirely on the driver's ID. So you'd access it like driver's one location.
Okay. What's the trade-off there?
Well, you lose the ability to do one single operation that affects both the driver and their location atomically at the exact same time. They become separate interactions.
Got it. All right, let's talk data types. The actual information flying back and forth, Booleans true false seems simple.
They seem simple, yeah, but DWACS warns they can box you in. His chat room example. Archived is true false. Allow chat box is true false. What if later you want to allow, I don't know, different kinds of participants? Not just bots.
We end up with a ton of Boolean flags. Allow guests, allow admins.
Exactly. It doesn't scale well. Sometimes a more flexible structure, maybe using an enumeration of fixed list of possibilities, is better for the long run. Future-proofing.
Okay, what about numbers?
With numbers, it's not just the value, it's the size. How many bits? 8-bit, 32-bit, 64-bit integers hold vastly different ranges. That impacts storage on both sides.
And floating point numbers have their own weirdness in how they're stored.
Right. And strings, similarly, need length limits. The receiver has to allocate space. Better to be a bit generous up front than have to make a breaking change later because someone needs a longer name.
Especially for identifiers, those need to fit.
Crucial. Now, null values. They can be tricky.
How so?
In many formats, like JSON, it's hard to tell if something is explicitly set to null, or if it's just an empty string, or maybe even omitted entirely. GWAX suggests strategies like maybe treating an empty string as a signal for use the default if empty isn't otherwise valid, or having a specific default keyword.
Okay, and numerations, those drop-down lists for programmer.
Yeah, enums. They help with validation, maybe even compress data slightly. But GWAX cautions against overusing them in web APIs. Sometimes they reduce flexibility and clarity compared to just using clear, documented string values.
Interesting trade-off. Okay, let's talk identifiers, the unique labels. Uniqueness is obviously key.
Paramount. But GWAX has a clever idea.
Yeah.
Include checksums in the identifier, like a built-in error check.
Oh, neat. So you can tell if someone mistyped it or if it got corrupted.
Exactly. Helps distinguish between doesn't exist and that's not even a possible ID. Then there are hierarchical identifiers, like we touched on. Books 1, pages 2.
Clearly shows the relationship.
Yeah, but the warning is, resources in that structure shouldn't really move between parents. Page 2 shouldn't suddenly belong to book 5 without a deliberate action. It implies ownership.
Got it. He also mentions UIDs.
Universally unique identifiers. Yeah, very handy, especially for databases. And a practical tip for preventing duplicate actions, like double charges.
Yeah.
Let the client provide a unique request ID. Don't try to guess or derive it on the server. It's more reliable for deduplication.
Makes sense. Okay, now the actions, the verbs. Create, get, list, delete, update. Stick to those standard methods when you can, right?
Absolutely. GWAX stresses this. It leverages existing knowledge. Developers already know these verbs, makes APIs consistent.
He makes an interesting point about delete and idempotence, though.
Right. Idempotent means doing it multiple times has the same result as doing it once.
Yeah.
GWAX argues standard delete shouldn't be idempotent.
Why not?
Because it's an action. You're requesting a deletion. If it's already gone, you can't perform the action again in the same way. It's different from just ensuring the state doesn't exist. Subtle, but important.
Okay. And there's also a replace method.
Yeah, kind of a standard pattern, too. Unlike update or pass.ch, which changes specific parts, replace swaps out the entire resource, ensures no old data is left hanging around.
But what if the standard actions just don't fit, like sending an email?
Exactly. That's where custom methods come in, things that aren't just CRUD operations. GWAX suggests using post, but with a colon in the path, like users123.sendPasswordReset or rocketsabc.launch.
The colon signals it's a custom action.
Right. And you need to decide if it acts on one resource, like sending email for user 123, or a collection, like deleting multiple users. Generally, target collections if it involves multiple resources.
Custom methods give flexibility, but GUX admits they bend REST principles a bit.
Yeah, it's a trade-off. A practical middle ground for things that just don't fit the standard model cleanly.
Okay. Often you don't need everything about a resource, right? Or you only want to change one small part.
Precisely. That's where partial updates and retrievals come in, often using field masks. You specify exactly which fields you want to get or which ones you want to change.
So just update the chat room name, don't send all the other settings, or just get the user's name and email for a list.
Yeah, much more efficient. Reduces data transfer. The mask is usually just a list of field names, maybe a query parameter for get teas, or in the request body for PAT-PCH updates.
Makes sense. What about removing things from nested structures, like maps?
That's tricky. GWAX points out that just setting a key to null might not mean remove it, and JSON doesn't really have an undefined value, so you might need other ways to signal delete this key entirely.
Okay. What about things that take a while, like processing a big file?
Long-running operations, or LROs. You need a way to track that background work, check its status, maybe get notified when it's done, like tracking a package delivery.
So the API call returns immediately, but gives you a way to check back.
Exactly. It usually returns some kind of operation resource. That resource has metadata, progress, start-in times, current step. And you need a way to find these operations, maybe a list operations method.
Can you just wait for it?
You can write code to pull the status, but GWAX points out that blocking and waiting indefinitely is risky. Connections drop. Custom wait methods might exist, but polling is common.
And for really complex stuff, there are jobs.
Yeah, that's breaking it down even more. First, create a job resource, configure everything, then use a custom run method on that job to start it. Gives you more control, lets you rerun things.
Okay. Now let's talk about relationships between resources. One-to-many is usually okay, but many-to-many, like users and groups.
Gets more complex. GWAX discusses using association resources. You create a third thing, like a membership resource, that links a specific user ID and a specific group ID.
And you can store info about that link there, like when they joined.
Exactly, or their role in the group. The alternative is custom methods directly on, say, the group resource.
Yeah.
Like add group user
Yeah.
and remove group user. Manages the link implicitly.
If you use those methods, what about errors? Adding someone twice? Removing someone who isn't there?
Good question. You'd use standard HTTP errors. 409 conflict for a duplicate add. Maybe 412 precondition failed if you try to remove a non-member.
And the big problem, deleting something that other things point to.
Yeah, dangling pointers. GWAX lays out options. Block the delete, cascade the delete, risky. Or just let the references become invalid and expect clients to handle it. He kind of leans towards the last one for consistency, even though it puts more burden on the client.
Okay, what about polymorphism? Resources that can have different shapes.
Like a shape resource that could be a circle, needs radius, or a square, needs side length.
How do you handle...
Well, the server might have a structure that includes all possible fields. Then validation checks that you only provide the right fields for the declared type, like a type field saying circle or square. You also have to decide, ignore extra fields or reject the request.
Got it. Sometimes you need to rearrange things. Copy or move resources.
Yep, custom copy move methods. Key point, the API service should assign the new ID for the copied or moved resource. Don't let the client pick it.
And what about child resources? If you move a folder...
The files inside usually have to move too. You also need to think about related resources, things that just refer to the moved item. Do those references get updated? It gets complicated.
And it needs to be atomic, right? All or nothing.
Ideally, yes. Copying or moving complex structures needs transactions to ensure it either fully succeeds or fully fails and rolls back cleanly.
Okay. Doing things in bulk. Batch operations.
Right. Perform the same action on many resources at once. More efficient and, crucially, often needs to be atomic. The whole batch succeeds or fails together.
Can you avoid repeating info for each item in the batch?
Sometimes, yeah. Batch methods might let you hoist common fields up to the main request level. GWAX looks at batch versions of standard methods. Batch get, batch delete, batch create, batch update. Each has nuances. like handling parentage and batch create.
What about deleting based on criteria, like delete all messages older than 30 days?
Criteria-based deletion, or purge. GWAX warns it's risky. A typo in your filter could wipe out way more than you intended.
Yikes, how do you prevent that?
He suggests a preview mode. The API first tells you how many things match your filter before doing the delete. Maybe even shows you a sample of what would be deleted.
That seems safer. Okay, Anonymous writes, logging data without authentication.
Yeah, for things like analytics or event logging where authenticating every single tiny write is too much overhead. Custom methods targeting collections like .log event. You lose some accountability, obviously, but it enables certain high-volume scenarios.
Makes sense. Okay, large data sets need pagination, breaking things into pages.
Classic pattern. Use cursors, opaque tokens. Request sends page token and max page size. Response gives results for that page and a next page token if there's more.
Simple enough. What about filtering, getting only specific resources back?
You need a way for clients to specify criteria. GWAX contrasts unstructured filtering, like a SQL-style string, with structured filtering, using a defined schema. Flexibility versus complexity, that's the trade-off. You also need to think about performance. How complex can filters be?
Can you allow custom functions in filters?
Maybe, but carefully. GWAX calls it breaking the glass only for really unique needs because custom functions can be computationally expensive.
Right. Import and export, bulk data transfer.
Custom methods, again, usually tied to a resource type. Import messages, export users. The request needs details. Where's the data, what format compressed, any filters.
How do you keep exported data consistent if the source data is changing?
Tricky. Maybe snapshotting the data or using database transactions. But GWAX stresses this isn't a replacement for proper backups. Different guarantees.
Gotcha. Okay, big topic. Versioning. Handling changes over time without breaking users.
Super important. You need checkpoints. Maybe even run different versions of the API side by side for a while. Versioning can happen at different levels, client libraries, the actual data on the wire.
And defining backward compatible isn't always simple, is it?
No. Does the change break existing code? Does it change behavior unexpectedly? Depends on user expectations. Renaming a field clearly breaks things. Adding an optional field, probably okay.
What are the main strategies?
GWAX outlines iterative, only backward compatible changes within a version, versus parallel. Release new, potentially incompatible versions alongside old ones with deprecation plans.
And semantic versioning, SEMVer.
Major minor dot patch.
Yeah.
Major for incompatible changes. Minor for backward compatible new features. Patch for backward compatible bug fixes. A common convention to signal the impact of changes.
Okay. Soft deletion, like a recycle bin.
Yeah, marking stuff as deleted instead of removing it permanently.
Yeah.
Add a Boolean deleted flag or a deleted state in an enum. The standard delete method just flicks this flag.
Yeah. Then you need custom methods for permanent deletion, expunge, and restoring undelete.
Exactly. And that deleted field should probably be output only. Clients shouldn't set it directly.
What about preventing accidental double actions? Request deduplication.
Use those client-provided request IDs we mentioned earlier. The server caches the response for that ID for a short time. If the same ID comes in again quickly, return the cached response instead of reprocessing.
Like a safety net.
Sort of, yeah. More like a short-term idempotency helper.
Validation-only requests. Checking if something would work.
Useful. Add a validate-only Boolean flag to requests. Default is false, do the action. If true, run all the checks, but don't actually save changes or perform the action. The response should ideally look like a real response.
Resource revisions. Keeping snapshots over time.
Like version history for individual resources. Useful for auditing. Legal documents. Can be created implicitly on every update, or explicitly. Needs revision IDs, preferably random, and methods like .list revisions, .rollback, .delete revision, but adds complexity, so only use if really needed.
What about network errors? Retrying requests.
Clients often need to retry transient errors. Identify which errors are safe to retry. Server issues, usually, not client errors. Use exponential backoff wait longer between each retry.
Add some randomness, jitter, to avoid everyone retrying at once.
Exactly. Avoid the stampeding herd. APIs can also suggest a wait time using the retry after header.
Okay, finally, security. Digital signatures for authentication.
Yeah, for stronger guarantees. Prove origin, prevent repudiation, can't deny sending it, ensure integrity. Uses public-private key pairs. Client signs the request with their private key.
Server uses the public key to verify.
Right. The signature usually covers a fingerprint of the request, method, host, path, maybe some headers, and a hash of the body. Crucially, include a timestamp or nonce to prevent replay attacks from just resending an old signed request.
Wow, okay. That covers a lot from DUX. Now, looping back to Ponelat and Rosenstock, they really push using OpenAPI, right?
Always, yeah. If you're doing HTTP APIs, they argue you should be using OpenAPI. They highlight tools like the Swagger editor for actually writing and checking your OpenAPI definitions.
And the definition itself includes
Paths, operations, GET, POST, etc. Parameters, path, query, request bodies, responses, status codes, descriptions, data schemas, examples, plus metadata.info, server URLs, tags, and importantly, security schemes, how authentication works.
And the big win is tooling.
Huge win. Swagger CodeGen can generate server stubs and client libraries in tons of languages directly from the definition. Tools like Prism can create mock servers instantly, so front-end devs can work without waiting for the back-end.
Based just on the OpenAPI file.
Yeah, exactly. It enables automatic input and output validation too. And it's great for testing. You can use tools like Postman or Swagger UI that understand the OpenAPI spec.
They push that API design first idea hard.
Very much so. Design the API contract in OpenAPI before writing code. Catch issues early. Use GitHub to manage the definition like source code branches, pull requests for changes. It becomes the central agreement.
And you can define things like filtering and pagination in OpenAPI.
Yep. Define the query parameters for filtering, the limit and cursor parameters for pagination. You also define all the possible error responses for each operation. Very thorough.
What about versioning in OpenAPI?
While the book discusses avoiding versioning if possible, OpenAPI itself can describe versioned APIs perfectly well. They also clarify differences between older Swagger 2.0 and the newer OpenAPI 3.x versions.
Okay, so wrapping this all up, we've covered a massive amount of ground. API design patterns, naming, structure, data, methods, LROs, batch ops.
Identifiers, relationships, polymorphism, copy move, pagination, filtering, versioning, security, and how OpenAPI provides that practical framework to describe and implement these things.
And the reason we dive into all this detail is about gaining that knowledge efficiently, right? So you can be well informed about how this underlying tech works.
Yeah, understanding these patterns helps you recognize what's going on in the software you use daily. Appreciate the thought that goes into making things work smoothly, even when it's machine to machine.
Which leads to a question for you, the listener, to think about. Considering your own work or just the apps and websites you use, can you spot examples where APIs seem to follow these patterns? Or maybe where they don't?
Yeah. What impact does that design, good or bad, seem to have on your experience? It's interesting to start looking for it.
Definitely. And if you want to go deeper on any of this, check out the sources. API Design Patterns by GUX and Designing APIs with Swagger and OpenAPI by Ponelat and Rosenstock. Think about how these ideas might apply in your world.